Thank you. Well, as far as up to now, Rosana Sanchez is not here. We are going to continue with the last lecture. In this case, Amelia del Rey, and this is a global atlas pocket app for renewable energy, and this is a multi-platform development. Good afternoon. Well, I'm going to introduce a project, and if we should get into the concept of open software. We think that we thought that we should use the values of open software, and this is the agenda. I'm going to talk about the context and origin of the project. I will watch a video about the solution that we obtain on the Global Atlas Pocket. After, I'll comment on some technical issues and how we did solve the problems, and I'll end up with some conclusions. Pro Developers, Valencian companies from the TIC sector with more than 20 years experience in the development of information technology solution with a strong geospatial character for sectors such as the port, public administration, environmental sector, transport, and so on. We are member of the Open Geospatial Consortium, and we participate with them in projects, and we promote that research and development in our company is very important, and we incorporate the results of our research to the product to our products. At the beginning, IRENA that was a competition that was organized by the International Agency of Renewable Energies. Then we presented our project, and we had very little time to prepare an offer, and we only had 3 months to present a bid, and we should be competitive in the market. Then in the framework of this project, IRENA is leading a project which is called Global Atlas, allowing you access to a data set, knowledge, and financial support in order to assess the potential of renewable energies for 67 countries and more than 50 institutes, organizations, and partners. Global Atlas incorporates a catalog with more than 1,000 data sets with global coverage. We have solar maps, wind, geothermia, marine energy. We have a geoportal in IRENA where users can have access to different services and all this information. You can also download the information, generate user profiles, and other utilities. My project is the application, the mobile application for this Global Atlas that allows you to have access to all the information published by this geoportal. Some of the requirements that were demanded is that it should work in the largest number of platforms possible. We started with this project at the end of 2014. This mobile application should be able to access data of the Global Atlas project through standards WMS and CSW. Some of the functionalities of the application should be to share information with social networks, provide the possibility of getting alphanumeric information, graphs for time data, and the display of these theme layers in 3D. I'm going to show you a video. Excuse me. Well, this is the video of the application. At the beginning, when we can do a selection of the work area in which we want to display data, because the application goes faster and the layers which are downloaded are only those with which we are going to work. So then we can load the different layers. We have different categories, as I mentioned before, and we can have access to the description of the layer and a preview of those layers. The background cartography is bitmaps and street maps. And here we can see that surfing, after I'll tell you how we solve this in order to get the effect that we wanted to with a seamless, quick surfing. Here we have a solar layer, and we can change the opacity of the layer. We can observe the captions, and we also have the description. And finally, what we can do is to display this layer on a 3D globe. We can also navigate on this globe, and we can make consultations. I'm going to stop the video, and I'll come back to the presentation. Excuse me. Well, there is a thing I didn't show, which is the obtention of charts, time charts. When we ask for specific information on a point. We wanted to cover the largest possible number of platforms which were available in the market in 2014, and then we saw that if we do the development for Android and BlackBerry, we could cover 50% of the market. On the other hand, we should have access to theme data that were contained in the GeoPortal and using the GIS standard. And we have GeoServer as a map server, and GeoNetwork was also used. Due to the little time we had in order to perform this, then we decided a multi-platform development using open software technologies in data display and web environment. So then we have a mobile app which was multi-platform access to data. We use a GeoServer as a map server. Some of the aspects, for instance, IRENA already has its catalog, because the client of IRENA already considered the 5 categories I mentioned before for developing the access to those data through the mobile app. We tried the API standard, CSW, but due to the configuration mode of the keywords in the layers, we were not able to have a good access. So then we were using the specific API of GeoNetwork. Not all the theme layers of Global Atlas can be displayed in mobile devices, so then we had to generate a category which is in the interface of the GeoCatalog as a mobile application, those layers that can only be seen in mobile. The mobile application, it does it has links to getting graphics, keywords, and categories, and geographical area. And the answer is sufficient to get the description of the layer and a preview of that layer. In the case of WMS, we use it for display of layers and information per dot and the representation of time data. So then the ideal scenario is that and the getMap requirement should configure the time parameters. So then we found that many queries to the WMS was saying it cannot be represented by graphs. So then we had to use text information in order to represent those graphs with a parser. And then what we did was the Apache Cordova platform for the multi-platform compilation for the 4 mobile platforms. And in the end, this is a web app that uses native apps. And for this, we use HTML5, WebGL, JavaScript, and CSS Open Layer 3 for the mapping display, SDK of the platforms, WebGL Earth, and Cesium for the 3D globe, the Cocoon GIS library. I will speak about this later more in depth, but we use it in order to improve the performance, and Grunt was helpful in order to automatize tasks. So this is the architecture. It's very simple, and I would like to mention something that made this project very complicated, which was the 3D display, because not all systems are able to move a 3D globe in a seamless way. So then we had different features, and we assessed 2 alternatives using Cesium and WebGL Earth. WebGL Earth was providing a seamless operation of the surfing, but presented some problems with memory. When we were alternating 2D and 3D views, then we had faults. And Cesium was solving this problem of memory, but the performance, especially in lower range terminals, was difficult. So then we created the Cocoon GL library, especially for the platform of iOS and Android. The mobile application takes a lot of space, and downloading is heavy. That has solved the problem of performance, but it's not enough for all the devices. This web hybrid application is a common project for all platforms, but we should say that the different platforms have different development and tailor-made developments. The problems that we found were the use of native components, sharing social networks, location, etc. For instance, there is a problem we could not solve, which is in the Windows Pro platform. We were not able to solve the problem of sharing social networks. The redimension and draw of web components on the screen that also needs a specific software with a specific code, and the development in 4 operational system does not guarantee that it works in all the devices, nor in all the operational system or all the versions. And the 3D globe also have different behaviors and needs a high level of tailoring. And the configuration of the parameter time in the WMS getMap is very important if we want to obtain virtual graphs using punctual information. And at the level of hybrid multi-platform web apps, they are an option. in opposition to the native development of the platform whenever the budget or the performance time is short. Advantages, we have a unique development and we save cost because if we develop for native applications, we have to multiply the cost by 4. We do not need a specialist in native SDK. The performance, the completion time is quicker, and there is the result is very similar. The drawbacks are restrictions in the performance if compared to a native app. We have to use libraries like Cocoon JS in order to obtain a better performance. The platforms have to be personalized, and it's a complex work to do. And that's all. And before finishing, I would like to thank my colleague Ignacio that was going to deliver this lecture, and all the technicians of our company that were able to develop this very complex project in only 3 months' time. Thank you. As far as Rosana Sanchez is not here, then we will start with the debate. Do you have any questions? Good afternoon. I had a problem for Romel, for algorithms. As I understood, it doesn't support a restricted direction or limited speed. I don't know whether you are going to implement this in the future, and how are you going to tackle this type of restrictions to move. There are sometimes directions which are banned in a network. Yeah, but the module for the analysis of networks allows us to define a field in the network that's covered. If you can only go through one street because it's a one-way street, well, that's what you do. And the algorithms, speed, for instance. That's the problem. With genetic algorithms, depending on the population that you have, by defect, you can need more time to find out the solution. But as far as this is everything done in the desktop, and is not an immediate solution for the problems. In this case of location and assignment, we didn't do any analysis of performance. For us, the time it takes is not important. A field of time speed limit. I know that you were talking about speed, and I thought you were speaking about the speed of algorithms for the problem of localization, assignment. We are doing that depending on the case. In this case, I'm going to ask a question to the three of you. Which was the most important difficulty that you found in the project, and how could you solve that difficulty? The greatest difficulty was related to the definition of the assessment function, and which were going to be the type of crossings that we could have between the chromosomes. How were we going to do the crossings? How were we going to define the assessment function? and how were we going to do the mutation. These two functions have to be present in a genetic algorithm. And once you do that, you define the populations and you run the algorithm. And finally, then you keep the best solution. For those cases, we will always have a good result after 1,000 iterations. It's a very good question. I'm going to tell you a bit that was an anecdote that I had. I went there with the aim of validating the approach and with important challenges. And one of the most important challenges I found was to change the mindset, the approach, the focus, because there you have people who are gurus in geographic information systems. I'm not an expert in SIGs, and the question is why are you going to change something that gave us good results? We do not want to reject what has been done. We just want to approach the problem from a different view. And regarding the platform, this can be used by people who has basic knowledge of information technology, but not necessarily are experts in geographical information. This is one of the main differences. And the other challenge was the setup of the stakeholders, the integration and call of social stakeholders, because it's difficult to find ways to motivate people to participate, especially in this kind of work, which is a PhD work. What are you offering to the person in exchange for him or her to contribute with his or her talent or intelligence? It has not been seen. In fact, we are still in a process of development. We have contacted the Mexican Association for Wind Energy, and we are waiting for their participant list certified because we want to involve the people from the academic world, the private world, and the public world. So this is another very important challenge that we have. In our case, as I mentioned, the building of the system was a complex issue, but perhaps the most difficult thing was to solve the 3D display of the different layers and in the resolution that we had that improved the performance, but that was not easy, and it was difficult for my colleagues to get that. Another question for Amelia. Was there any possibility to implement any other mobile platform in case that it could become a commonly used device? What happens is that we would have to compile. It allows the compilation of the 4 platforms. So we would use 5 platforms instead of 1. Yeah. Okay, thank you.
Right, over there. I've got a question also here for Jose. Do you think that strategic assessment what you've developed is important in other countries? And do you think it's useful to move away from traditional sources compared to renewable sources? not to separate them technically, shall we say, but obviously, but when we look at the lobbies, the lobbies who are managing the renewable energies, if you understand what I'm saying. Can you just say that first part? Do you think that the strategic assessment which you have developed can be exported to other countries? Yes, absolutely. I'm quite optimistic, to be honest. What we're doing is we're taking concepts and approaches of the work which has been done in Europe, is being done in Europe, and also trying to copy the law and to paste it in our environmental protection legislation. We have to take into account the complexity of the reality for a country like my country, which has got a peculiar reality, we could say, and so it's a huge challenge to adapt this knowledge. And the challenge, which what we're optimistic about, is that once we manage to achieve this in an environment, in a quite a difficult environment, complex environment, we should be able to adapt it to other countries, even here in Europe, because what we've seen is that actually there's been a lot of work done. Well, sorry, very little work done for integrating information, spatial information, and for strategic environmental assessment, and little incorporation. And okay, then finally, a little doubt I have for Romel is when we're talking about the localization and assignation, is it available at the moment within the module of networks for any use or any user? Is it available but not published, you're saying? I wanted to bring out an article, in this case in some journals, and once I publish it, then yes, we should be able to free it up so that anybody can read it. That's fantastic. Thank you very much for that. Right, well, if there isn't, we don't have any other questions, I'd like to say thanks very much to all the speakers for their speeches. They've been extremely interesting. I would like to once again say thanks to the gvSIG association allowing me and the official college of topographers and engineers, and also this year we've been sponsors, because we also are aiming to promote the Congress TOCA, which I suppose you've seen it in the documentation which you've been given. And I'd just like to say that I'd like to invite you to this Congress, which will take place next year in Toledo. And once the call is open, from the 26th to 30th of October 2016 in Toledo, there will be a congress related to geomatics, in which we have 5 mini congresses. One is for the climate change, land territorial observation, land registry, geoinformation, and we also have reference systems and cartography issues. All of you are invited, and if any of you should have any doubt, you can always ask me. So thanks very much to you all. Tomorrow the workshops will begin at 9 o'clock. Okay, just to like to remind everybody here. Okay, thanks very much for that.